Hey everyone, so in this video let's write our own module to implement an adder, a full adder, and I'm not going to be worrying much about the signs, so we'll just make it an unsigned adder. So let's go ahead and create our module for the adder, and this will take three inputs, that will be A, B and the carry in, and the outputs would be sum and carry out. So this is my module, and within this all I have to do is I have to mention that A is an input, so input wire A, input wire B, input wire C. And now let's make a 4-bit adder, let's say. So what I'll have to do is here I'll have to say 30, here as well I'll need 30, and then I'll say output sum, which will again be a wire with 4 bits, so this will be 30 again, and then I'll have my output wire C out. So this C in and C out are not going to be arrays, that's because these will just be 1 bits, either 0 or 1. And next all I have to do is I just have to do a continuous assignment, so assign C out comma sum, because I want C out to be the most significant bit. And what should this be equal to? It's just A plus B plus C in. And that's it, I've created my adder module. So let's go ahead and create our test bench for this. So module test bench, and here let's create a register for A, and this will be again 4 bits. There will be a register for B, which is again 4 bits, and I'll have a single bit register which is my C in, and I can have wires for the sum and C out. So the sum needs to be 4 bits and my C out needs to be just a single bit. So let's go ahead and write the initial block now. And here what I'm going to do is I'm going to assign some default values to my variables. So A is, let's say, a 4-bit binary, which is, let's say, 0101, that's decimal 5, and my B will be a 4-bit binary again, and let's make this 0110, that's a 6, and we won't keep a Cn for this, so Cn is a 1-bit binary 0. And now all I have to do is I just have to display my, let's add a delay here and then display my sum and C out, so C out here and display sum. And here what I'm going to do is I'm going to create an instance of my full adder module, so I'll name this full adder, and then my inputs are A, B, C in, and my outputs are sum and C out. So let's go ahead and try this out. And as you can see, this compiled fine. And now what I need to do is vvp adder.vvp, and as you can see, this gives me a C out of 0 and a sum of 11, which is correct because this is my 5 and this is 6, so 11 is the output that I was expecting. So in this video we've created the adder, which is working perfectly fine. There's still one problem which I'd like you to think about. What if I wanted to convert this to an 8-bit adder or a 16-bit adder? What would we have to do? And we'll discuss that in the next video, so I'll see you there.